We're now going through question 9 of the 2022 O-Level A Math Paper 2. The equation of a circle is x squared plus y squared minus 16x minus 2y plus 40 equals to 0. So this is the typical form for the expanded form of the equation of a circle. Find the radius and coordinates of the center of the circle. So in order to find these two things, it's very helpful for you to convert the expanded form of the circle's equation to the factorized form. Okay. So how we're going to do that is by completing the square. So we can group the x terms together. So x squared, I'm just shifting things around. Okay, I'm shifting the terms around. Minus 16x plus y squared minus 2y plus 40 equals to 0. So it's exactly the same as the original equation. I'm just shifting the x terms together and the y term together so that it's easier for us to see when we're completing the square. So you will complete the square for the x terms separately from the y terms. Okay, so now just focus on the x terms. When you complete the square, you should get this x minus 8 whole thing squared minus 8 squared. Okay, when you complete the square for y, it's y minus 1 whole thing squared minus 1 squared. And then plus 40 equals to 0. So x minus 8 whole thing squared plus y minus 1 whole thing squared. When you combine the constants together, you'll get negative 25. Okay, but we're going to shift that to the right-hand side of the equation, so it will become positive 25. So this is the factorized form for the equation of a circle. So from here, you can see the center of the circle will be at 8, 1, and the radius is just the square root of the right-hand side. So it's just 5. Okay, for the next part, find the shortest distance of the circle from the line y equals to 2x, and hence explain why the circle does not intersect the line y equals to 2x. So there are two parts here, but we need to do the first part before we can even think of the second part. Okay, so maybe a bit of a sketch can help us visualize this. So I'm going to draw a line. Okay, so let this line be the graph y equals to 2x. Okay. And I'm also going to draw the circle. Okay, from the question, we already know that the circle does not intersect the line, right? So I'm going to draw it as such as well. Okay, so this will be the center. And the shortest distance from the circle to the line will obviously be the perpendicular distance. Okay, from the center of the circle to the line. Okay, so this is perpendicular. We know the center, let's call it O, is 8, 1. There's the coordinates 8, 1 from the previous part. We don't know the coordinates at this point. Let's call it x. Okay, we don't know the coordinates here. But we know this is the graph y equals to 2x. Okay, so let's first try to find the equation of this line, of that shortest distance. Okay. So first we know the gradient. Okay, so gradient of OX is equal to negative of the reciprocal of the gradient of the line y equals to 2x. Okay, because it's perpendicular to that line. So it's equal to negative half. Okay. So we know that the equation of the line of the line OX is y equals to negative half x plus c. So let's solve for c. We know that this line OX also has a point 8, 1 on it. So O lies on this line. So you're going to sub in those coordinates into this equation. Okay, so 1 equals to negative half times 8 is 4 plus c. So, sorry, it's negative 4. So c is equal to 5. Okay, so therefore, OX is actually y equals to negative half x plus 5. Okay, so we know now the equation of the line OX. And we know OX and the line y equals to 2x, they meet at the point x, right? So to solve for the coordinates of x, we need to solve these two equations simultaneously. So we sub in y equals to 2x into the equation we just found, which is y equals to negative half x plus 5. So if we substitute y equals to 2x in, it will be 2x equals to negative half x plus 5. Okay, so 5 over 2x equals to 5, and x is equal to 2. If x is equal to 2, y is just equal to 2x, so it's equal to 4. So now we've solved for the coordinates of x, which is 2, 4. Okay, this is still not the final answer, okay, but it's going to help us find the final answer. So the shortest distance of the center of the circle to this x, okay, will just be the distance between the two sets of coordinates. So recall, okay, to present your answer, you have to say that you're finding the shortest distance of the center of the circle to y equals to 2x. And this will be square root of the difference between the x coordinates, 8 minus 2 squared plus 1 minus 4 squared. So x2 minus x1 whole thing squared plus y2 minus y1 whole thing squared. And then you square root the whole thing. And that will be square root of 45. And to 3SF, that will be 6.71 units. Okay, next part C. The point C lies on the circle and CD is the diameter of the circle. Find the coordinates of D. Okay, for the previous question, actually, we have to explain why the circle does not intersect the line y equals to 2x, right? Okay, so we can see because the distance between the center of the circle to x, it's 6.71 units, which is greater than the radius of the circle, which is 5, right? Remember from the previous question, we knew that the radius was 5. So because the distance is greater, it means that this x is outside of the circle. Okay, so the circle does not. Okay, so since OX is, okay, since shortest distance is greater than the radius of the circle, the circle does not intersect the line. Okay, so that's the explanation. Okay, the next part C. The point C lies on the circle and CD is the diameter of the circle. Find the coordinates of D. Okay, so we're just going to let the coordinates of D be x, y, but we're going to sketch out this diagram to help us visualize a bit better, okay? So I'm going to draw a circle. And again, we know the center is 8, 1. And the point C is 11, 5, right? And it lies on the circle. So it's going to be somewhere here. Okay, this is C. So to form the diameter, we have to draw this line and D will be somewhere here. Okay, the thing is, because this CD is a straight line and the circle, the center of the circle passes through this, right? For us to figure out what the coordinates of D are, we can use this relationship, okay? So not only is the length here, okay, let's call the center of the circle O, not only is CO equal to OD. Okay, we already know that because those two are the radii of the circle. But not only that, but we will also know that this, if I were to draw like a right angle triangle, so a line down vertically and a line down horizontally, right? So this is a right angle triangle. This horizontal distance, okay, will be equal to this horizontal distance. Okay, let's call this A. This will also be A. Similarly, this vertical distance, let's call it B, it will also be equal to this vertical distance. Okay, so if we can find those units A and B, we will be able to figure out D quite easily. Okay, so how do we find A? So we can see the x coordinates. Let's compare the x coordinates, okay? From C to O, the x coordinates went back by 3 units, from 11 to 8. Okay, so if it went back by 3 units, we can expect from O to D to also go back by 3 units. So 8, if we go back by 3 units, that will be 5, right? Similar to this, we'll do the same thing with the y coordinates. So the y coordinates got reduced from 5 to 1 as we went from C to O. Okay, so that's a gap of 4 units. So B is 4 units, which means from 1 to get to the y coordinate of D, we go down by 4 units as well. So this will be -3. Okay, so the coordinates of D will be 5, -3.